Hello friends, welcome back to the channel. In this video, I thought we could work a little bit more on our compiler that uses LLVM. It's very small right now. All it handles is integers and strings, and it will just take the parsed AST and compile it into the intermediate representation for LLVM, and then tells LLVM to compile that into a binary and run it on the fly using the JIT execution engine. And it works. It works. It's pretty cool. I had a lot of fun doing that. Check out the previous video if you haven't seen it. But in this one, I thought we could make instead of using C-style strings for just calling, just passing those to printf. Whenever it sees a string, I actually want it to use our string class, which would let us do all kinds of fun things, appending and accessing characters easily, substring, and I don't know what else, prepending, all kinds of stuff. And it is a growing string, so it will handle all that. So how do you call C++ this class from LLVM? Well, from my understanding, you don't. That someone can correct me if I'm wrong, if there's some way, but in all my journeys on Google, I have not found a way to do that directly. What seems to be the easiest way to do this is to give yourself an extern C function that calls the C++ code that you want. So that's what we're going to be doing, and hopefully we can get it working in this video. So stick around if you want to see it. All the usual disclaimers. I don't really know what I'm doing if that's not clear. I'm kind of learning as I go and Googling and all that. So if you came here for a how-to, I'm very sorry. I'm sorry. It's not here. It's not this one. So how can we do this? So what if we just say, Natalie string pointer nat string, and we'll just prefix it since now we're in like the C global kind of namespace. Yeah, we're not in our Natalie namespace anymore. I'm going to prefix everything. And I guess we'll just give it a const char pointer stir, and what it will return, I guess this just needs to be the declaration, and then we'll go to string cpp and put this here and say that this returns a new Natalie string stir. And that's all we're going to do on the Natalie side. And we're going to go back to our LLVM C++ code here. And, what do we do? We, I guess, need to do this function create thing that we did for printf. So it's going to look a lot like this. And the let's get back our declaration or our function prototype here, returning a string pointer, and so we're not going to teach LLVM about this type. My understanding is that you just use an int pointer, an I8 pointer, which is sort of like this the way of doing like a void star in LLVM, I guess. At least that seems to be in all the example code I saw. This was very common, this I8p. So we already have that. We'll just use this one up here. This is going to be nat string prototype. We're going to get a function type that returns an I8p and takes an I8p, and this needs to be a vector type star. I'll just use parens here, I8p, and then this is false because it does not take this boolean here is does it take a variable number of arguments? It does not. What did I do wrong here? I did something wrong, obviously. I might need to actually include vector, but I don't think that was the error that it was complaining about. Oh, because I was using parens. Yes, okay. Yeah. Well, that works. So we have our prototype, and then we want to actually create the function. This is going to be net string prototype. External linkage is going to be net string here, and get the module. Yeah. So now we have these this nat string function. I'm going to pass it into the walk tree function for now. I know that's gross, but I'm not. We're not going for elegant. We're going for usable. Nat string function, and we'll refactor later. We're just trying to see if we can get something to actually work. Walk tree, walk tree. Okay, so the next thing we want to do is actually call this function from the builder. So we want to emit IR that calls the function, and it's going to look a lot like this create call. We still need this global string because we have to actually have a C string to build it, and that's fine. So we'll do this. Let's separate. Let's give ourselves some room. So we're going to call nat string with the string, right? Nat string function with the string, and I think I can just call this. I can't call it string. I have so many things called string, so let's call this the C stir. We'll call this the stir pointer. We'll call this the stir pointer, and we'll call this the nat string. Okay, yeah, it's kind of gross. Nat string, and then for now, we're going to turn right around and extract the C string from it and call printf. It'll be clear hopefully soon why I'm doing it that way. But for now, just have to trust me. Nat string to C stir. That's going to take a const Natalie string. Now this returns const char pointer and string cpp and boop, boop, boop. Return boop, string string C stir. Okay, so it's just the opposite. We're just converting it back into a string. Not really converting it. We're just getting a pointer to its internal data, its internal C string. And so guess what? We need another function. So we're going to, we don't need that. Why is that still there? I'm going to copy this nat string to, well, let's do it a better way. Let's copy paste. Copy paste is better. Nat string do. Okay, and nat string to C stir prototype do. Okay. Actually, nothing changes in the prototype, does it? Because it returns an I8P and it accepts an I8P, so nothing is different there. This is going to be different to C stir, and yeah, you guessed it. We're gonna pass it in because again, just trying to make things work. Function star nat string to C stir, and then pass it here too. Okay, so now let's call that. I want to explain why I'm doing it this way. if we get far enough in this video, I want to have a puts, or it actually compiles the puts into a printf. So we're not going to keep these printfs here. I'm not sure if I'm going to do it in this video or in the next video, but just I want to explain it to you because I'm not sure that you believe me that this is stupid. No, it probably is stupid. Nat string to C stir, nat string. That's what we're going to do here. And then we're going to do back to, I know this is gross, back to cster. Just to be clear what's happening, nat string to cster function. Is that not what it is called? Yeah, there we go. Function. Now it's happy. And we're going to pass in the nat string. Back to cster, and then this is back to cster. Okay. So let's just recap what we did. We are, well, I think the IR will show. What are you? No, I should do a creep call. Back string. Back to cster. Do I have to? Oh. Yeah, it's happy now. I don't know. I guess it was just taking a second. So let's take a drink. Should we run it and see if we get a seg fault? Let's do rake bin LLVM and run this. Okay, we definitely got a seg fault. Okay, so now we're in debugging mode. One thing I found in debugging mode is to change this back to interpreter, and you will get a better error sometimes. The segmentation fault I have debugged in GDB and LLDB, and you don't get a great backtrace, or at least I haven't yet. So my way of debugging is to switch it back to the interpreter. Try to execute an unknown external function nat string. Okay. There's one thing I've forgotten, I believe. What did I forget? Let's just make sure. String header HB. I did extern C this, so it should have the right. It shouldn't be mangling the name in any way. The other thing that I have to remember to do is to pass our dynamic. I learned that the hard way through many hours of debugging. I don't want to say it wrong, so I'm not going to try to explain what it does, but it tells the compiler to leave the symbol there even though it thinks it might not be used or something like that. So because the compiler thinks that our symbol isn't being used, everything's not in the, okay, yeah, I'm just going to give up. It's something you have to have for LLVM. If you want to call a C function. So now let's try this again. Yeah, I told you I wasn't going to try to explain it, and I ended up trying to explain it. Someone in the comments can explain it. Okay. We got something. We got 304. Why did we get 304? Let's change that back to the JIT now, and just for funsies, make sure we get exactly the same thing. So we'll look at the emitted LLVM code here. Oh, see, that works. Okay, so that's the problem with the interpreter. Sometimes these strings aren't working with the interpreter, and I'm not sure why. I think we had that in the last video a little bit, but this is actually working now. Does it work with two strings? Yeah, seems to. Cool. Well, that went pretty well. Let's see if we can do what I want to do now, which is I'll show you what it looks like. I want to be able to say puts 3 and puts high, and I want to be able to compile these two things. So I want to explicitly have to say puts, and it's not going to actually be a function call. We're not implementing function calls yet. We're just going to fake it. We're going to, if we see a call with a nil and a puts, then we're going to compile very special LLVM code to do that printf stuff. So let's try that. Now, if I pass bin LLVM puts 3, it says, I don't know how to handle node type 10. And that's code that we have right here. So if I go and look at our parser node 10 is call, that is fantastic. So let's just make a call. These are in alphabetical order, so let's just keep that going. Call. And now what? Now what? I guess let's go look at the call node. Do we need a way to get things out of it? We already have the receiver and we have the message. So we'll say if node receiver is nil, I think, no, node type is node type nil. Yeah, nil. And the node message is puts. Then we're going to do something else. Otherwise, we're going to just say, I don't know how to compile function calls yet. We'll do that, and we'll call abort and fix my indentation. Thank you, receiver. Okay. So I'm going to say auto call node is static cast call node star node. Now I can do call node and call node message. Is that better? I think that's going to go away soon. Now we're going to copy paste our format string stuff. Oh, okay. No, I can't do that yet. I need variables. I need variables? Or I need, what do I need? I don't need variables. So let me think about this for a second. If I have puts 3, I guess that gets sent in with the... Oh, this isn't a call node, is it? Oh yeah, node with args. How does that work? It's been a while. Node with args, where you at? I need some tags. There we go. Node with args. And you get a vector of args. So should I walk? Okay, I'm just going to think out loud here. I think we want to assert that there's only one arg. We want to call walk tree for that arg. And coming back from walk tree, don't we need the type? Don't we need to receive a type? And then switch the format string of printf based on type returned. Seems right. What am I missing? Look, I can just return this num from walktree. Yes? Okay. What if we just return this? Why are you unhappy? Because this is a void. Okay. What type is it? Should not return a value. Okay, well, it's now a char. Now what are you going to tell me? LLVM constant int star. Let's go look at constant int. It's a value. Is a string a value? Instruction is a value. All the constants are values. Operator. So is a let's just try it. I don't know. What's the worst that could happen? So if I do this as a value star, this using namespace is going to be a problem because I have a value in Natalie and LLVM has a value. I'm going to have to probably not use this. Natalie node, Natalie block node, Natalie call node. Yeah, this is gross. It's gross. Parser, Natalie string. It's fine. I don't even mind. Okay, are you a bit happier now? So now you're returning a, yeah, that's an old error. That'll go away in a second. So we're going to return the integer. And we're going to call the yeah, let's do this. Assert call node args size is 1 dot size, and I don't think I can return that. Can I? Can I return it? I'm going to say num. And this is the walk tree of, let's say, actually, let's just put that back to num. We'll say auto num is walk tree call node args dot first. I don't have a first. Oh, of course, I have to pass in all these things. Print function, nat string function, nat string cstir function, and we're gonna pass that into the create call, and we're returning this. I'm not doing the switch on the type yet because I don't know how to, so we're just going to assume it's a number, and we only change this code and this code. This will definitely break if we run the string side, but we might be able to know what's going to happen. Let's just do a number by itself, because I want to see what's happening. Non-void function does not return a value in all control paths. That is true. That is true. Let's just put what if I return this? And this is an abort. That's a return. That's a return. That's an abort. This block. Ooh, we want to return auto. Let's say values last result. That's bad. Fix me. I don't know. Not null putter. Need something better than that. We'll say last result is that, and we'll do return last result. Does that work a little bit better? What are you complaining about? Can I jump from switch to this? Oh, I need some curly braces. And now everyone's happy. hopefully. Let's run this again while my editor catches up. I've definitely got a problem in Vim. It takes a long time. Okay, that didn't break anything. We didn't use the value, so I guess it didn't really emit anything. But if I do puts 3, what does that emit? So this is kind of working. Here's our format string, which is the %LLI, and then we pass in, oh, actually it was all the way to there, so that whole thing. And then we pass in the number 3, and it prints it. And it works. Okay. Now how are we going to make the string stuff work? So here's our nat string. Let's say value. This is value now. Switch value. Now how can I know what type it is? I don't see that. Type? Get type. What does this do? Get type if it's equal to if it's one of these, then let's assume it's a Natalie string for now. Oh, that's not how you use a switch statement. Case. Can I actually do that? I don't know if I can or not. Switch. So if it's a string, we're gonna do that. If it's a builder, it's one of these, then we're going to do this code. If it's a string, then we're going to do this code. I know the indentation is all messed up. There we go. Switch. Yeah. So you can't. I'm guessing I can't really do this the way I want to do it. This might work. Well, we're going to turn this back into a C stir by calling that. And then we're going to pass in the value. And the format stir is a %s. And then we're going to do C stir here and return this. Ooh. Maybe. Yeah. What happened down here? Got too many curly braces or something. Now, is that better? Okay, it's getting better. This is supposed to be value. Okay, assuming it's a Natalie string for now. I don't know. There's probably a better way to do that, but if this works, then I'm going to be ecstatic. Puts 3 and puts high. Puts 3 and puts high. Will it print 3 and high? Oh, puts EO. We'll say let. I can't put an apostrophe. Let us go. Let's go. Actually works. Why do we keep recompiling it every time? Okay, I don't know. It works. It works. Oh, it's so cool. Here's our let's go. Here's our hi. And this needs to be reused. Oh, but it's so cool. It's actually emitting and it's handling. Okay, this is the coolest part about LLVM. Maybe this is obvious to people. I don't know. It wasn't obvious to me at first. By just having variables in our C++ and calling like this builder create call. No, that's not a good example. Like this. So we're creating this constant int and we're returning it and then we're storing it in value. That automatically gets turned into a temporary variable right somewhere. Actually it doesn't. It just gets passed in. The call to printf does. Fascinating. Like, how does it choose? I guess constants can be passed directly, but if there's a call involved to a call to a function involved, then it has to create a temporary variable. So I don't know. That's pretty cool. Maybe that's just how it does it. Maybe it has nothing to do with my variables here. That would make more sense. I thought it was doing something magical. But in any case, it is generating the IR in a way that I don't have to think about all these temporary variables, which if you've been watching any of our Natalie videos over the last year or so, you know that we call temp a lot because we are managing these temporary variables all by ourselves with no help, and it gets very cumbersome. And the fact that the LLVM builder is doing all that for us is so cool. That's so cool. Well, that's it for this video. I think we're going to commit this and pretend that we did something fantastical and amazing. If you have experience with LLVM and you want to help me out here, help us all out, please leave a comment below. I know that people who watch these videos do read the comments and they do get a lot out of the comments. So you can help us all out. Not just me, you can help other viewers of the video. But this is just awesome. This is so cool. What else can I say? Let's commit it. So what did we do? Well, we added this our dynamic flag. We added some extern C style functions with no name mingling so that we can call them from LLVM. We brutally messed with our walk tree function signature by just passing in a bunch of extra junk. Don't worry, we'll work on that later. We added a step to our tree walker that handles call nodes, and specifically it only handles the puts call because I didn't want to be printfing everything all the time. So now we can call puts on stuff. This got simpler. These other branches of our switch statement, now we just return the constant int. And for the string, we return, you know what, we can get rid of these. We return the Natalie string because that's a value. The result of create call is a value. That's pretty cool. We did have to get rid of our using namespace, which makes me sad, but you know, now that I think about it, I think I could have prefixed value star with LLVM value. Maybe I should have done that. Oh, well. And what else did we do? I don't know. I guess that was about it. Let's commit this, and then I'll come back and get rid of these comments. We'll say, oh man, I don't even know what to like how to describe what we did. Add puts, let's see, compile puts into printf, a call to printf based on type given, based on arg given, or something like that. I don't know. We're learning. And then let's go amend. Let's get rid of all of this stuff. Assuming that string for now. Any other comments that I can get rid of? I think that's good. I need to make this use like an environment variable or something. That's okay. Let's amend that commit and push. And that's it. Hey, thanks for hanging out. That was a lot of fun. I really enjoyed that. I hope you come back for the next video, because I think I want to work on variables, maybe, where you can say x equals 1 and then puts x. We'll probably just have one variable scope, the global scope, for now, but yeah, it'll be educational. Keeping track of the type of the variable will be a lot of fun. So definitely check back soon for the next video, and I guess I'll see you then. Bye.